Hello YouTube, Jerry Kirkpatrick here, and I know I was supposed to be building the guard over the top of the grinder in this episode, but after having the machine turned on, after I got everything done down in here, the noise was just horrendous, and also the vibration that was coming out of the platen mainly itself. So the first thing I did was remove 3 of the stake tools, the Pexto stake tools that I had strapped to the framework here. It was a very convenient place to put them and still have easy access to use them when I needed them. So I've taken that out, those off, and the next thing that I noticed that might be creating imbalance was a Allen head cap screw in the back. That cap screw has been on there ever since I built this whole disc grinder. So that might be some of the vibration, that head swinging around. Probably not very much, but I'm going to change it anyway. The next thing is I checked the runout on the side of the disc, and it was nominal. It was probably a 64th of an inch. But then I checked the runout on the front, on the platen itself, and it was way out. So in that, I was only using probably half of each disc, unless I pushed real hard and either deflected the platen or overcome the runout. The next thing I checked was the inside of the platen here. There's a bushing to step the inside bore of the disc itself down to the diameter of the motor. So what I'm going to do first is take the platen off and check the runout on the shaft itself. Make sure that the shaft in the motor is turning true, and then I'll find out what I need to do, if I need to do something else in the bushing itself. I turned it with the equipment that I had. So back in the 70s, I didn't have much of a lathe. I had to use somebody else's lathe to do it. So let me get this platened off, and we'll check the runout on the shaft. So I've gotten the disc and the bushing off of the disc grinder, and after I got this removed, I took a very small single cut file and removed all of the garbage, rust and such off of the outside of the shaft, and gently filed the 2 areas where the set screw was sitting. I did not break the surface of the shaft itself. So after I got it all clean, I measured it, and it came out to be a perfect 5/8 of an inch diameter, 625. and I checked it for round, and it was turning perfectly round. And then I checked the end play, nice and tight. The bearings, shook it all over, up and down, sideways. Bearings are nice and tight. I turned it on, and you could just hear a hum. It was just perfect. I didn't hear any bearing. I didn't feel any bearing imperfections or anything. So the motor and the shaft are just what they ought to be. So I pulled the bushing out of, or the sleeve bushing out of here. I measured it, and it was 10 thousandths larger than the shaft. I put it on there. You could wobble it all around. Not good. So there's 10 thousandths right there. I measured the outside. I measured the inside of the platen of the hub here, and it's a perfect 7/8. Tried this in here, and we have another 10 thousandths play in there. So there's 20 thousandths out of round once the two set screws are set. So I went out into my scrap pile, and I found this shaft here, and it measures 872 thousandths, which is 3 thousandths small. So that is a very, very nice fit. It's 3 thousandths. So what I decided to do was put 3 rows of center punch marks in there, and that would raise the OD, and now it would be a press fit in here. And once I got those done, I'll cut this to length so the end of this is flush with the outside edge of the platen of the disc here, and bevel where the cut is, and then I'll heliarc weld this in place. And then I will grab this up by the hub and get it perfectly concentric and take any play out of it so it's not wobbling in the lathe, and then I'll bore it out to 5/8. And then I went to the hardware store and got some 5/16 18. I got 3/4 and 1 inch set screws. So when I get this back on the motor, I'll use the set screws. I'll find out which one works best, and I want to put a jam nut on the outside. So I'll tighten both set screws down, tighten the jam nut, and it should be good forever, for another 30 or 40 years. But one thing I thought might be of interest to you is how I laid out the 120 degrees to put these 5 center punch marks in here. So I've got this blued up, and I've got the cross in here, finding the center. Let me get the camera moved. I'll get this clamped to the table, and I'll show you how I laid out to get the 120 degrees for putting the center punch marks in. So here I've got the 7/8 bar stock with the horizontal and a vertical line marked on it. I'll just place this down, Here's a set of pony clamps that I made back in 1970, probably 76, when I was building Webco and Diamondback bicycles for holding the tubes in the welding jig. So I'll just take and put that in there. This is 7/8. So I've got a piece of 1/4 inch and a piece of 3/16. That's half. So I'll turn this until I have that line lined up with that thickness there. Then I'll take my square, actually protractor, from straight up to horizontal is 90 degrees. So I just have to set my protractor to 30 degrees. That comes up to the 120. Just set that on there, slide it over until I'm right on the center mark, and make my line. Then I come to the other side. Bring this right up to the center punch, or the center crosshatch there. Make another line. There's 1, 2, 3 lines that are 120 degrees apart. So let me get this cut off, go over on the lathe and get this all figured out, drill the hole and everything, and I'll meet you back over on the disc grinder. So here we have the hub, actually a spacer between the shaft and the hub on the disc finished. Took quite a while. Actually, I wound up making like 4 of them because the hub is not centered on the bore. And I didn't find that out until I got everything made, installed, and turned it on. That's when I found out that I was holding it in the lathe on the hub, and everything looked true. Once I got it mounted, it still had the run out. So I took it back off, chucked it in the lathe on the face of the hub, and that's when everything turned out fine. It makes almost no noise whatsoever. The disc is glued on just a little bit off center. I'm sure that the disc is somewhat out of balance, but I don't have any way, I don't have the rollers to check the balance. But other than that, it's 100% better than it was, and a lot less noisy. So I'm finished with this part of the repair or build of the disc grinder, and I promise the next project that's coming up is the shield that will go over the top of the disc to keep that array of sparks flying all over the place. And I've got a pretty unique way of fixing the shield so I can put it in 2 different places. So when I run the disc in one direction, It will cover all the way over to give me a place to run out here about 4 inches up. If I desire to run it in the reverse direction, I can just take it off, put it over here, and with one snap everything will be in place. So I think that might be an interesting build for you to see. So thank you very much for watching. Give me a thumbs up, subscribe and ring the bell. See you later.